Hello, my name is Stepan, and today I want to tell you about my project, Recognition of Multispectral Images. So let's have a look at our agenda. In this presentation, you will know what is multispectral image, relevance and usage, main task and problem, solution and analysis, and conclusion. So what is multispectral image? A multispectral image is a collection of several monochrome images of the same scene, each of them taken with a different sensor. Each image is referred to as event. A well-known multispectral is a RGB color image consisting of a red, green, and a blue image, each of them taken with a sensor sensitive to a different wavelengths. So, relevance and usage. Multispectral images are used in military, space, farming, document and painting analysis, healthcare, forensics, environmental monitoring, detecting algal blooms, surveying and mapping, multispectral imaging cameras. So, if you go back to the history, we will know that multispectral images were originally developed for military target identification and reconnaissance. In military, it is widely used for military target tracking, landmine detection, ballistic missile detection. So let's have a look at another usage. It is widely used in space-based imaging. For example, it is used for agricultural research and mapping of a man-made natural disaster. It is widely used to prevent deforestation. As you can see, researchers from the Amazonian forest and its deforestation. Despite the use in farming, multispectral imaging helps farmers minimize the use of sprays, fertilizers, and irrigation while increasing the yield from their fields. It is widely used in healthcare to diagnose health issues. Moreover, it is used to diagnose health issues at the level of individual cells. In document and painting analysis, it is used to recover some ancient documents. As you can see an image, on the left image, you can't see any word, and on the right, you can. So it is definitely good. Also, it's used to detecting algal blooms. It's used to prevent their spreadness and to prevent of dying thousands of inhabitants of marine. So let's have a look at our main task. Our main goal is to investigate the recognition of multispectral images using machine learning. In our case, we will investigate data collected from aircraft objects, for example, planes, drones, missiles, and others. So we start with the problem of classifying multi-class instances. For now, we know about planes, drones, missiles, but in future it will be much more. So to solve this problem, you can use different methods like extreme learning machines, nearest neighbor, naive Bayes, decision trees, support vector machines, hierarchical classification, and also our choice to use neural networks. So what is neural network? Neural networks are a set of algorithms modeled loosely after the human brain that are designed to recognize patterns. They interpret sensory data through a kind of machine perception, labeling, or clustering raw input. The patterns they recognize are numerical, containing vectors, into which all real-world data, be it images, sound, text, or time series, must be translated. Neural networks help us cluster and classify. Here you see a simple neural network on the right. So our solution will be a neural network with one input layer and one output layer and two hidden layers that will classify what type of like object is appeared. For now, we have this data. It's green, blue, and red, and infrared. And also, it is a classifier plane. So problem solving. Our first step is to our neural network we will initialize with a random place and we'll train it until we have a good results. Here is how our neural network will look like, but we will have a much more neurons. So here's data, our data. It will be numbers from 0 to 1 and the classifier. For now, it's plane, but we will have a rocket and drones. So let's have a look at the UML diagrams. Here you can see a use case diagram and a class diagram. In the use case diagram, we will see how our program will be used and how it will be interact with other programs such as multispectral station or some user. On the right, you can see class diagrams that how our structure of project will be seen. Here is a neural network and input data. We are input data neural network and predict it. So here you can see a cooperation diagrams. That's how our program will interact with each other, and the sequence diagram, how it's from where it starts and where it ends, and how it looks for start to the end. Here is the activity diagram. Here you can see the state of our object and how it's doing during his usage. And the component diagram, how it will be seen using files. For this, we will use the Python, Matplotlib, TensorFlow, Keras, Seaborn, NumPy, and Pandas. So that's how our data looks. Here's our data set. Now I have a column blue, green, red, infrared, and data types, float, and object. That's how some data statistics. Here you can see a mean, standard deviation, minimum and maximum values of our data, some percentage of data. And here is the data statistics. That's we can say a data relation. So we can say that we can classify our data perfectly. That we have the green rounds is in one group, orange in another, and blue in another. So we can classify it. So now we should experiment with activator to choose one of them. So we'll see how ReLU interact with various activators. So it is good interact with sigmoid and softmax function. Tanh activator is good with ReLU, sigmoid, and softmax. Sigmoid interacts good with sigmoid and softmax, and softmax is good with only softmax. So in our choice will be a sigmoid with a Tanh activator. We will use two of them. So also we should choose an optimizer. So you can see that RMS probe, Adam, and AdamX is a good optimizers. For our choice will be Adam. And we should provide epochs. As we can see, we can find a stable epoch. So we choose 1,500 epochs to stabilize our model. So here's a program implementations. For on the left, we can see how we are reading the data from a CSV. Then we're creating a model and adding the layers with an activators. Then we're configuring it with an optimizer and training a model with epochs. Yes, a prediction and its results. That we can see that there's no wrong predictions, only right predictions found. Here is a model statistics, some model accuracies that we can see that with increasing in epochs, we have increasing in accuracy and decreasing in losses. So our model is good. Here is a program usage. So our user will will input the data and we will load our model and then we predict it with model. So user input the data and then you can see a prediction. So we have successfully investigated and analyzed multispectral images. Also, we create a neural network that classify what type of aircraft object is flying. As a result, user can input data in floating numbers and will see the class. So thank you for your attention. Hope you like it.